Okay, this is number 15 on your first review. This one, I ask you to figure out which one fits the data on your test. You're going to have to do, I'll tell you which one, either linear, quadratic, or exponential. So we'll do one of each on this one just to make sure that you guys know what to do. So if I go to my calculator to get this information in again, you're going to go to Stat and then Edit. And then you put in the points exactly like they show you on the table. And then from here, we're going to do a linear regression on this. So I was doing that one. We're going to go to Stat, and then we're going to go to Calc. Then we're going to go to linear regression number 4. And then press Enter. And I'm going to put this one on y1, so alpha y equals over to y bar. And y1 is going to be my linear regression. And then press enter, enter, and calculate it. So zoom 9 is what sets this up so that we can see our data. I don't have my plot turned on, so if you ever get to where your plot dots aren't on, then just go to y equals, go up to your plot 1, and press enter, and that will turn it on. So now if I do zoom 9 on this one, now it goes. So the linear regression is not really necessarily a good fit. But if I need it, the equation is right here, 71.5x minus 89.02, so 75.9, 71.5. So y equals 71.5 minus 89. That wasn't a great fit, so let's look at a different one. So I'll go back to this, and we're going to do the same thing, Stat, Calc. This time we want to run a quadratic regression. Quadratic regression, L1, L2. You can make this y1 and it'll take away that first one there, but I'm going to leave it. I want you to be able to see that. So I'm going to put alpha y equals y bar, and then I'm going to put this on y2. So the cool thing about this is now I'm telling it to copy and paste to the second line. On your test you won't have to do this, you'll just have to do one. Press enter. And the second model is y equals 15x squared minus 48.7 and plus 51. So let's check this one out and see how it works out. We already did zoom 9, so the window should be zoomed right up to those points. And I'll just hit graph. So there's the linear. Ooh, this one is better than the linear, so let's try exponential one. So Stat, Calc, number, we're going to 0, exponential regression, press enter. This time I'm going to put it on y3, alpha y equals, my y bar, I'm going to put it on number 3 this time so we can see all of those graphs together. So this is now y equals 16.8, because that's where the a goes. The b is going to go in the parentheses after this, with the x as the exponent. Those are always the formats of these. So the b is 1.59 or 1.6. Okay, so now I'm going to go to my model on the calculator, go to y equal, or to the graph, and see how this one fits. There's the linear, there's the quadratic. Ooh, that exponential is looking pretty good. So I would say this one is the exponential graph. So that one would be the best fit for this one. So if I want to find the number of stores open in 2000, if this is 1986, the year 2000 would have been 2000 minus 1986 is 14 years after 1986. So my equation here is y equals 16.8, 1.6 exponent of x. The stores opened in 2000 is going to be an x value of 14. So you can plug that into the equation now. Y equals 16.8, parentheses 1.6 raised to the 14th power. And you can calculate it from there. But since I have this on my calculator, let's go there and look at this. I'm going to turn off my y1 and y2. You can do that just by clearing this. And again, on the test, you're not going to have to go to this, do all three of them. You just are going to have one of them. And if I graph this one, I want to know in year 14 what this looks like. So I go to second table, and year 14 is 10,674. So when we did this on the calculator in the table, we got 10,674. If we plug this into y equals 16.8 times 1.6 raised to the power of 14, we end up with 12,105.105 stores. The reason why there's a difference like this is because this is the approximated or rounded version. So there's these things called round off errors that happen. If you do this on the test, make sure you show me your substitution step so I can check that it's right. I can kind of tell if it's close, but you can tell just rounding off this much of it changed my values pretty significant, or my store numbers pretty significantly. So either way is fine. Either y equals and then second table is how I did that one, or you can plug it in. Just make sure and show your work on the test.